in this example, we want to graph y equals 2 times the cotangent of x. So in order to graph this, we need to figure out the values of a, omega, and b to determine what the vertical stretch is, what the period is, and if it's been shifted vertically at all. So a is 2, so that means that we have a vertical stretch factor of 2. So vertically stretched by 2. There's no reflection or anything because a is positive. We know that omega is 1, so that tells us that the period is pi divided by 1, or pi units. And then b is 0, so there's no vertical shift. No vertical shift. So now we can use this information to help us graph our cotangent function. So if you recall, the cotangent function has one cycle. The first cycle of the cotangent function starts at 0 and goes to pi units, typically when it has a period of pi, which in this case it does. So we're going to start at 0 with a vertical asymptote. So we're going to have a vertical asymptote at 0. Let's label our axes first. So just like we did with the all the other sine and cosine functions, we're going to cut our period into quarters because all of our major values are going to happen at the quarter marks. So pi divided by 4, those are going to be where our major points, like the key points, occur. So we're going to label all of our pi over 4 units. So 0, pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, 4 pi over 4 is pi, and then we can also go in the negative direction. So we have negative pi over 4, negative 2 pi over 4 is just negative pi over 2, negative 3 pi over 4, negative 4 pi over 4 is negative pi. So let's go ahead and graph this function. So we know that at 0 we have a vertical asymptote. And then, so our cotangent function starts and ends its cycle with vertical asymptotes. So we're going to have a vertical asymptote again at pi. And then in the very middle, halfway between our two vertical asymptotes, we hit our x-intercept. So at pi over 2, we're going to have an x-intercept. Let me use a different color for this. We're going to have an x-intercept. And then at pi over 4, normally we would hit a value of 1. When a is 1, we hit 1. But in this case, because a is 2, it's been stretched by a factor of 2, so it's going to hit up here at 2. And then at 3 pi over 2, we normally hit negative 1. And again, because it's being stretched, we're going to hit down here at negative 2. And then just fill in your curve. Fill in your curve here. So there's one cycle. And then we can draw another cycle in the negative direction. So we have a vertical asymptote at 0. We're also going to have one at negative pi here. And then again, halfway in between, we have an x-intercept. And then we're going to hit at 2. And then at negative 2. A way to remember this is just whatever your value of a is, the left one hits at the positive value of a, this one hits at the negative value of a. And then sketch your graph. And there's a second cycle of y equals 2 cotangent of x.